right, so one final video for this section, and that is the arc length. The arc length in polar form gets pretty ugly, and so we're not going to spend a lot of time on this. I'm going to expect that you're going to just whip out your calculator to do this, but you still need to know how to set up the integral to do it on your calculator. So let me remind you of your arc length in parametric land. In the parametric curves, the arc length looked like this, and then in polar curves, it looks similar but not identical. So there's a reason why it ends up looking like this, but I know you don't care, so I'm not going to even go into it. So let's go ahead and use this. So arc length is just the integral of f of theta squared plus f prime of theta squared. So it's relatively simple. It has the same form, but it's not quite as understandable as to where it came from. So the arc length in parametric land, it's directly descended from your distance formula. Whereas here, it's not as clear where it's coming from. So let's compute some of these arc lengths. Let me just jot this down. R equals 2, where theta is between 0 and 2 pi. And then the next one is going to be R equals 2 minus 2 cosine of theta. That's a cardioid, where once again from 0 to 2 pi. And then the last one is R equals theta, where theta, now I should warn you that we don't always work out the entire, so this is only, not all arc length formulas will go from 0 to 2 pi. So just so you know, it's just these three happen to, but the ones on your homework aren't like that. Okay, so here's my first problem. So we have f of theta is 2. F prime of theta is 0. And so the arc length formula is the integral from 0 to 2 pi, in this case, because here's alpha and beta. 0 to 2 pi of the square root of f of theta squared plus f prime of theta squared. And this is exceedingly easy because you end up with this. Which makes sense because this is just a circle. And so when you're asked for the arc length of a circle, essentially you just want the circumference. And the circumference of a circle is 2 pi r, which is what we got. This one, not so easy. So let's do r prime is going to be 2 sine of theta. Yeah, this is f of theta. Here's f prime of theta. So now we want the integral from 0 to 2 pi of the square root of f of theta squared plus f prime of theta squared. Now I am so tempted to work this out because I see the whole cosine squared, sine squared. In fact, why don't I just do one simplification? Whoops, I'm bleeding down into the next problem. So let's just simplify it a little bit, but then I'm going to whip out my calculator. So this is going to be 4 minus 8 cosine of theta plus 4 cosine squared theta plus 4 sine squared theta. And so hopefully you recognize that as that stuff is just 4 times cosine squared plus sine squared, which is 1, 4 times 1. So this whole thing ends up being 0 to 2 pi of the integral of the square root of 8 minus 8 cosine. So this just helps me to not have to type as much into my calculator. So I'm going to go ahead and type this in to my calculator while I pause the video. All right, well, I went to the trouble of typing all of that into my calculator, and the answer ended up being surprisingly simple, just 16. So like I said, I'm sure I could simplify that in some way, but I'm not going to try right now. Final one. This is actually, I think it's called the spiral, Archimedean spiral. Anyway, r equals theta, and we're just going from 0 to 2 pi, so this is going to be the, oh, that's f. And so, well, I'll just turn this into an f prime is 1. So this is going to be the integral from 0 to 2 pi of the square root of theta squared plus 1 squared. Here for sure, theta squared plus 1, I don't want to have to mess with. So calculator time. So give me a sec. Let's see, we got theta squared plus 1. All right. Yeah, nowhere near as nice. So 21.25629. I'm just curious. Sometimes I divide my answer by pi to see what happens. That didn't turn out nice. So, because sometimes a number like that is a multiple of pi, but it isn't in this case. All right, so once again, you've got questions. I have answers. You're going to have to ask me those questions in class, though.